Welcome to the Database Management System session. My name is Jeff Ash, and I'm a software engineer here with Basis. I've been with Basis since 1998, and the database management system is one of the key areas where I've focused my attention and my work here at Basis. And that's what we're going to be talking about today. So we're going to be looking at a quick review and a feature summary of the DBMS. For those who are new to it, it will help you understand what capabilities are available. For those who may already be familiar with it, it'll be kind of a nice refresher or a reminder of some of the key features. We're also going to be talking about some replication enhancements and improvements that have been made. We're going to be looking at how some of those improvements can be used as part of a disaster recovery strategy within your organizations. We're also going to be looking at full text index enhancements and how those can benefit you. We're going to be touching on some security enhancements that have been made. And finally, we're going to wrap it up by talking about the data dictionary HTML and SQL script export capability that's been added to the Enterprise Manager. So we have some exciting things to look at today. BBJ's DBMS is a powerful blend of technology that provides both low-level and high-level access to data. This makes it an extremely powerful and flexible solution. So what are some of the features that the BBJ DBMS offers? Well, first and foremost, it defines, manipulates, retrieves, and manages your data. It does this by allowing you to access that data directly from the BBX language using read and write operations, but you can also do this from the SQL language, and this is a much more familiar language for a lot of people these days. It also provides you with an ODBC and a JDBC driver to allow third-party access from both native Windows applications as well as any Java applications out there available. It provides fast lookups using different types of indexes. Those included would be standard SQL indexes, as well as something that we call a full text index. And that's something we're actually going to be looking at a little bit more later in this presentation. It provides user and group access management, and there's a couple of different ways that it can do this. We're not going to go into detail on that, but we are going to look into some security enhancements, as I mentioned in the overview for this presentation. Also provides the ability to replicate your data to another machine or another location. And so that is something we're going to be looking at here shortly as well. It also provides data encryption capabilities. And so this helps to better secure your data and make sure that those files, if someone were to get a hold of those, that they couldn't make any use of those without the encryption string that tells you how to decrypt that data. And then finally, we also offer change auditing capabilities as part of the DBMS. All right, so let's dive into some of the interesting things about this presentation. So first and foremost, let's start off with replication and some of the use cases that we have for it. Replication allows you to replicate selected data files as well as directories onto a target machine. So think of your live production system as your source. That's the source of the data that you're wanting to replicate. And then you'll replicate it to another machine or another location, and that would be called the target. Now, this allows you to offload querying and reporting operations to one of those targets, which is one particular use case for this technology. You can also use it to create kind of a live backup of your data, because replication keeps those targets as close to in sync as possible. And so you essentially have a live backup of your data at any time. You can also use it as part of a disaster recovery plan, which we're going to be talking about here shortly. You can help mitigate some risks of ransomware attacks. And that's an important feature that we've added. And again, we'll be talking about that here shortly as well. And it is available to BBJ, Pro 5, and Visual Pro 5. Now, it's part of the BBJ product, and Visual Pro 5 and Pro 5 can access this functionality by using the BBJ Pro 5 data server as its way of accessing those data files. So with that simple switch, you can provide replication support for Pro 5 and Visual Pro 5 applications. Okay, so before going into some of the features that we've added to help mitigate the risk of ransomware with replication, let's talk a little bit about what ransomware is. So typically ransomware involves encrypting the target's data and then demanding a ransom to be paid in order to decrypt that data. So an attacker would target you and your business. They would hack into your system, and then they would encrypt your data and then demand payment in order to decrypt it. So your data is essentially useless until it's been decrypted. Traditional backups could actually back up the damaged data. So you may say, well, I'll just go to my backup. Well, your backup may have already been damaged by that, or it could be older. And so restoring from an older, unharmed backup could actually result in the loss of current data, and that could be a problem for your organization. And restoring from a backup may also require additional system downtime in order to return to normal operations. So these are some factors that you definitely want to consider. Let's talk now about how the BBJ replication feature can offer some protection against ransomware attacks. But first and foremost, I do want to point out that replication is only one aspect of a complete ransomware and disaster recovery solution. So don't look at this as a magic bullet to provide you protection from any kind of damage due to a ransomware attack. Again, it's just one piece that you'll want to incorporate into your disaster recovery strategy. Now, replication passes along all of the write and remove operations from the source to the target. And this is an important distinction between another form of replicating your data. BBJ replication does not create a dumb byte-level copy of the source to the target, but rather what it does is each write or remove operation that occurs on the source will then be told to occur on the target as well. And it happens in the same exact order as it happened on the source. And that's an important distinction. So when you do a write operation on the source, you say write record, the source writes the record, and then it tells the target, hey, write that same record. So notice it's not copying from the bytes of the data file itself. It's sending over the write operation that was told. And that's an important distinction. Now, what this does is this essentially allows you to have a live backup that is also instantly verifiable. So let's talk now about how this ransomware protection actually works. Well, if a file on the source is encrypted via an attack, BBJ recognizes that the file is no longer valid, and it immediately halts replication of that file. The source may be encrypted by the attack. However, the target remains unharmed, and that's because of the way, as I pointed out, how replication works. It doesn't copy the bytes of the file at the low level. It sends over successful file write and remove operations. So remember that live backup that I pointed out? Well, what you can do is you can immediately verify the integrity of that live backup, and then this allows you to perform quicker restoration after resolving the vulnerability that led to the ransomware attack in the first place. So let's take a look now at a demonstration of how this actually works. All right, so let's start off by creating a replication job. Now I'm going to go through the replication wizard here rather quickly, just because the specific details of it are not really necessary for this particular demonstration. But we're going to be creating a named database instance replication job. We're replicating the Chili Company database and going to replicate it to our local machine here just to keep things simple. You would probably be replicating to another machine to keep things safe so that you weren't putting all of your eggs in one basket. But as we continue to move through our replication job wizard, we'll select the database that we're going to replicate and continue to move through. And as I said, I'm just kind of glossing over these parts of setting up a replication job because they're not particularly important for our discussion here. So we hit the end there, we hit our summary, and we'll hit finish. And now we have a replication job running. All right, and I did do a little bit of hand waving here because it does take a few minutes for a BBJ replication job to get initialized and up and running. And so ours is now, and so let's take a look at what that did for us. So when we look at the data file directories that were created, you'll notice here bbdict and data, those are our source, or think of those as our live production system. Now, since our replication job is set up to replicate for demonstration purposes to the same machine, it created these directories on the same machine, but these would be our target directories. So bbdict.replicated and data.replicated. These are going to contain our replicated target data files. Now let's go back into the Enterprise Manager and take a look at the database that was created for us. So we have one here called Chili Company. That would be our live production or our source database. This one here would be our target. So the Chili Company underscore, and then this unique identifier. So that's our target database or our backup. And we can go over here and take a look at that. This is our source database here. And you can see the contents of the category table. That's the one we're going to be working with here in our demonstration. And we can see that there. And then we can see the contents of the category table on the target database. So notice this is our target database, and you see the contents match up. So the record we're going to be changing is this particular one, condiment products. And so let's go back over here, and you'll notice here I have an update statement ready to go, and I execute that. Let's execute a select statement here. And we have our select statement, and notice the record now does not say condiment products, but now it says yummy products. Let's go take a look at our target database. We'll run a query there. And as you can see in real time, it's also updated. So you can see how now we have a mirror copy of that live production system. Every change that's made on the source occurs on the target. Now, let's say that we are attacked. So someone perpetrates a ransomware attack on us, and they come in and they decide they're going to encrypt our database. So in this case, we're just going to encrypt the category table, but to keep things simple. So I'm going to encrypt it. That file is now encrypted. And let's go back over and try and query our data. So we're going along, our application's working fine. We get attacked. We suddenly find out, oh no, what's wrong? This looks like a file corruption issue because it says get key description by number is not supported for this type of file. You wouldn't ever expect to get that kind of an error message on a standard mkey file. So now we say something happened. File corruption. In our case, we were just attacked. So if this was doing a byte-by-byte replication of that file, what would have occurred it would have copied over that file and those that encrypted file over to the target. So now the target would have a destroyed, unusable data file as well. But because of the way that BBJ replication works on an operation-by-operation basis, as soon as BBJ recognized that that file was not what it expected, it quit replicating changes to that file. So now let's go take a look at the target. So as you see here, we just tried to query the source. It's broken, right? So now we query the target. It still works perfectly fine, and we have all of our data intact. So what happened is essentially now our target is a perfect snapshot of the last valid operation that occurred on the source. So it's really cool in that way. So now how would we recover from this attack? Well, basically we'd want to go in and make sure the hole was plugged up, preventing anyone from coming back in and continuing to perpetrate these kinds of attacks on us. Once that's done, then we can restore back to the state that our database it was in the moment that that attack occurred. And the way that we can do that is simply to go in and we would probably likely shut down BBJ services and then swap out these directories here. In this case, to keep things simple, I'm just going to copy the category data file over back into the live production one, since we happen to know that that is the one that's broken in our case. So I replace it there, and then now I go back in and I query my data, and it works perfectly fine. So in a real life situation, might take a little bit more to get things back in order. You may have to copy directories from the target machine back over to the source machine, restart BBJ services. But as you can see, it's a relatively simple, straightforward process of recovering from that ransomware attack. And it's all because of the way that BBJ happens to handle the replication operations in the event that a data file on the source becomes either corrupt or intentionally damaged. One last thing I'd like to point out in this area is that if you happen to need a done-for-you solution for your system, Basis does offer a complete offsite disaster recovery service. So what you'll want to do in that case would be to contact your Basis account manager, and they can give you all the complete details on that. So not only have we provided you some assistance in preventing ransomware attacks, we've also enhanced some of the features of replication to now support the replication of encrypted data files in a much more robust manner. So encrypted files use an encryption string or a password to encrypt and decrypt the data. Now, prior to BBJ 21, replication required use of a mode string in order to pass in this encryption string. Now, the problem is that this may be undesirable to have this encryption string stored in your replication job configuration, and also the encryption string may not even be known. We do have a particular customer who hides the encryption string from anyone that uses their software. It's not readily available. Even the developers don't have access to the encryption string. So how would you set up a replication job of encrypted data files if you can't pass in that replication string? Well, BBJ 21 introduced automatic handling of encrypted files using the encryption string configured in the data dictionary. So this is a really nice feature that we've added. Now, what this does is it requires selecting the database replication option. So it doesn't work when you just simply select random data files to be replicated. You do need to select that database replication option, and you must have the encryption string set for the table's definitions. The encryption strings will stay secure in this way because that encrypted table encryption string file is also encrypted. And it's much easier to set up and manage this way. So you don't need to put that in the mode string. It's all handled for you automatically. And now let's go ahead and take a look at a demonstration of this particular feature in action. And we're back over at the Enterprise Manager now. And we have a table here called customer_ENC. And this is an encrypted version of the customer table found in the Chili Company database. As you can see here, it gives us an indication. This is a new feature in the Enterprise Manager that lets us know that the table is in fact encrypted. If we double click on the table and open the table editor, we can also see that there's an encryption string present. Now it's masked out, so we have no idea what the encryption string is, essentially the password for encrypting and decrypting data that's going to be written to that file. So we have no way of finding out what that encryption string is. And in fact, that may be something that our company has decided they don't want any of us to have access to. So how do we then handle creating a replication job? Well, in the past, as I pointed out, replication jobs required us to specify a mode string for that value. And now it handles it automatically. And so let's take a look at just how that works. So we're going to create a replication job here. We'll just call it Chili, keep it simple. Now, one of the key things that we need to keep in mind here, as I pointed out earlier, is that we do need to select replicate a named database instance. If we choose a list of one or more data files, it's not going to be able to automatically go and find that encryption string for us. And so we need to choose the database option. So we hit next. We're going to specify our host of where we want the target to be created, username and password for that host. And we'll continue through, and we'll just skip ahead to the interesting stuff here. So we're going to select our database, and we're going to select the encrypted database. That's the one we're interested in. It's going to create us a new database as a target, and that will be where all of those replicated files will wind up. We hit next, and then we see our properties that are defined. In this case, there aren't any additional properties beyond dictionary and data. All of the tables that we want to replicate. We have the customer_ENC table there included. We want to replicate that. And so notice I'm not having to specify anything additional here to handle that encrypted file. It just goes right through just like any other replication job. We continue on through, we hit our summary, we hit finish, and now we have a replication job that's automatically handling encrypting that file. Now, as I said, it's going in and automatically finding out this encryption string here. It's extracting that from the data dictionary in order to populate that mode string automatically at replication time. All right, and for the sake of time, I went ahead and did a little hand waving and let our replication job create all of the target data files and data dictionary files. And so now we can take a look at what we will see once our replication job is up and running. So now we have, as you can see here, our original source database, which is encrypted. We have our encrypted target database here, which in this case, it is on the same machine, just to keep things simple. We have our encrypted table or database over here, and we can run queries on that. So as you can see here, I did a select star from our encrypted table, and we have all of our data. And then we can come over to our encrypted one, and we can look at that same information here as well. And we can see that all of the data matches up. So now we're going to do an update here on our primary, our source, our live side of the equation. And we execute that update statement. And you can see it updated it. Let's do a quick select here, and we can see that it did in fact update our last name. And then we can come over to our encrypted target database. We can execute that same query, and we can quickly see that it did in fact update that last name on the target as well. All right, so let's move on and talk about another really exciting and powerful feature of the BBJ DBMS, and that is the full text index. So full text indexes differ from a standard index or a key in BBX terms. They're built using Lucene technology, and Lucene is a best-in-class search engine that we incorporate into the BBJ product that allows us to perform these lightning fast searches of your data. It's not part of the data file, but rather it's kept in sync when any file operations occur on those data files. And this is important, and it provides lightning fast lookups of your data in ways that you can't quite get using standard SQL operations. For example, you can perform much more complex searches when you're using a full text index than you could using something like a like operator or an equal or a less than or a greater than, or even a regular expression, much more complicated querying. Also, you can search within large text columns. So where you do have limitations when you use equal or like or less than or greater than, those kinds of operations, when you use those with a standard SQL index, you're limited on where the value that you're searching for appears within the string in that particular column. If it's somewhere in the middle of the string, then we can't optimize on that, and so we can't make use of that index. However, with full text indexes, we can, and that's what's really exciting about it. But not only that, you can also search multiple columns simultaneously, which again adds much more power to your searching capabilities. And you can even search a table as well as its related tables, those tables that have foreign key connections on them. Now, this feature is only supported in enhanced data dictionaries and ESQL files, but just know that we have this powerful capability where we can kind of walk the tree of the relationships between tables and do searches in that way too. All right, so we've taken a bit of a high-level overview and look at full text indexes. Now let's go ahead and lift up the hood, take a look underneath at some of the inner workings here. In particular, we're going to look at analyzers. So full text indexes use something called an analyzer, and this helps to determine how the text will be analyzed or interpreted. So should we ignore punctuation? Do the punctuation marks, hyphens, periods, question marks, at symbols, do these things have meaning in the context of the information that we're searching for, or can we just drop those? Well, in a typical English sentence, we might just drop the punctuation because it's stuff that we're not particularly interested in. We're more interested in the individual words. But a part number, we might need those punctuation marks in there. Do spaces have meaning? Again, another good question. A typical English sentence, we can drop the spaces. We don't need to index the spaces. We're more interested in the individual words. But a part number, those spaces may have meaning. Should the text be interpreted as multiple words or as a single token? Another question, another good question. So prior to BBJ 2102, BBJ supports a single analyzer for all index segments on a table. Keep in mind that any one table can only have one full text index present at a time. That means that all of the columns that you're interested in searching using the full text capabilities would have to have the same analyzer. And you can imagine maybe how that could become a problem. So what if the columns in the index have data that should be analyzed differently? So you have a name, and then you have a part number. Those may need to be analyzed differently. Description, an email address. Again, those things could require a different analysis method. So BBJ 2102 introduces per column analyzers. So these analyzers can be different for each one of the columns that are included in the full text index. It supports built-in as well as custom analyzers. So you can actually write your own analyzer based on the needs of your particular organization. Dramatically improves the flexibility of the full text indexes, as you can imagine. And there is much less confusion when building searches and interpreting the results. This is an area where many people have stumbled over the years because of the way that analyzers work. When you don't think about how the analyzer is actually breaking down the data, then it can be very easy to put in a search, expect certain results back, and get something completely different than what you were expecting. But the best way to understand this really is to just take a look at a simple demonstration of how analyzers work and some examples of how different analyzers work with different sorts of data. All right, so over in the Enterprise Manager, let's take a look at how these analyzers work. So I've created an item_mod table, and it's based off the item table in the Chili Company database. So if you're familiar with that table, some of this may look familiar to you. Now you'll notice here in the item mod table that I have modified the item num column just a little bit. In the standard Chili Company database, it's just simply numbers, so there's only digits present in there, no hyphens, no spaces, no special characters. But what I've done here for our example is added hyphens into the item num values, as well as some letters. And that will help us to understand the use of these analyzers. As you see here, the descriptions include a list of English words, standard English phrases, green chili pistachios, and that will also help us to understand how these analyzers work. So now that we have a little idea of what the data looks like, let's take a look at what we've done on the item mod table. So I've created a full text index, and I've included the Apache standard analyzer for the description and the item num columns. The Apache standard analyzer is going to be the one that's used by default, but we can change that, and you'll see what that does here in a moment. But for right now, we'll just leave it as is. And we are creating our full text index. And now let's go back over and do a search on it so we can see how it behaves. Now you'll notice here I've entered an asterisk. That's just a wildcard character. It means return all of the records in the entire table. And you can see here that it returned gives us the value of the item num and the description and so forth. So we can scroll through. We see some item nums that have 0D in them. We see some descriptions that have chili. So let's try a few queries here. Let's look for the word chili. So we look for chili, and it returns all of the rows that have the word chili in the description. We can also search for values that would be present in the item num column, because that's also part of our full text index. You'll notice here I did 0D, and that pulled up the values that have 0D in the item num. Makes sense. So, however, what if we were looking for all of the items that had 0D hyphen? So we said, well, I know that it has 0D followed by a hyphen, and I'm interested in all of those values. So I put in an asterisk before and one at the end, the wildcard characters. And when I look at that, my first response would be, yeah, that would be the search that should return what I'm looking for. However, when I hit enter, notice I get nothing back. And that may be very confusing. It's actually doing exactly what it's supposed to do. That's not a bug. That is working exactly how that analyzer is designed to work. Again, as a reminder, let's go to 0D here again, and now it's returning it. So why did it not return 0D when I also included the hyphen? That's because of the way the analyzer works. So the standard Apache analyzer, what it does is it looks at the value. So tortilla press here as an example, it would analyze this as tortilla being one token, press being a second token. So it's word-based. So it ignores the spaces because that's not of interest in the description. You know, when you're searching, the space doesn't really have meaning in and of itself. However, in the item num value, the hyphen actually has meaning. So in a word-based analyzer, the hyphen wouldn't have meaning. But in our case here, this item number, we really do want to include that hyphen. It's meaningful to that value. And so the analyzer that would analyze this as individual words, 00, 0D, and 21 as separate words, that analyzer is not what we're looking for. So if we go back over to our item mod definition here for the full text index, and we change the item num column to use a basis white space punctuation, what that means is that it's including all of the white space and punctuation characters as meaningful values when analyzing it. We save that, it recreates our full text index. Notice description is still going to work on a word-based analysis, which is exactly what we want. But now item num is going to behave a bit differently. And so let's take a look now. So if I do 0D, notice now it doesn't return anything. So you may be saying, well, why did that not return anything? Well, that's because those hyphens are meaningful. It indexed the entire index num value as a single standalone token. So in that case, then we would need to include wildcard characters, and then that would return the 0D. We can also include those hyphens that I mentioned, and it will also return the values with those hyphens. And so as you can see, it really depends on the type of analyzer that you choose to use as to how you're going to be able to index and then eventually search for the data in your full text index. And now, since we've given you the ability to specify it not just at the table level, but at the individual column level, now you can index the data appropriately and according to your own specific needs and the specific makeup of that data And you can do all of that very easily right there when building your full text index. Let's talk now about some of the security features available in the BBJ DBMS. First off, let's do kind of a review of what's available, and then we'll go on to talk about some of the new features that we've started offering. So we have username password authentication. This is something I think most of us are familiar with. You pass in your username, your password. The DBMS will decide if you are who you say you are. If you are, then it will assign your permissions based on who you are. So we have legacy database permissions, and these support simple read, write, or read-only level of access. Now, understand that those legacy permissions apply to the entire database as a whole. So you can give someone read-write access to the database, read-only access to the database, but you don't have any further granularity to specify individual tables to one user or another, or different kinds of write operations. However, we do also offer object-level support, and this supports standard SQL user and role permissions for things like select, update, insert, delete, those kinds of things. So you can assign individual permissions to a particular user or group of users so that they can perform a select operation on a table, but they're denied access to other tables. They can perform update operations on certain tables, but denied update operations on other tables. Maybe they can add data to one table, but not delete it from that table. Those kinds of things. So you have much more granularity and much more fine control of user access to your data. And then finally, we also offer what we call remote connection security. And what this does is it allows you to limit access to ODBC and JDBC third-party applications. Now, you may be saying, well, why would I care about that? Well, what if you wanted to provide access to your data to a reporting tool or to another application where you wanted them to be able to read the data, but you don't want them to be able to perform update or insert or delete operations outside the context of your application? Because keep in mind, most of these applications will update, delete, remove, add data according to certain business rules. And you probably don't want users to be dropping data willy-nilly out of a particular table or group of tables without the control of the business intelligence that's inside your application. So what this does is it allows you to say, hey, incoming connections from a remote machine using ODBC or JDBC, they can only read this data. They can't write to it. Now that we've reviewed some of the security features, let's talk now about a new security feature that we have added to the BBJ DBMS, as well as the admin API. So in version 2102, we added support for the use of what we call an authentication token. And an authentication token is basically, it's a way of identifying a user that doesn't require the password to be involved in the use of that token. And that's an important distinction there. So now the tokens are generated using the admin API. So what you do is you make a call to the admin API and you pass in a username and a password, and then you're returned an authentication token. That authentication token identifies the user, but now the admin API can just forget that username, forget that password. It doesn't need it anymore. And you also don't have that password as part of the token either. But that token, because it was generated by BBJ Services basically says, yes, I certify that this token is valid and a valid way of identifying the particular user that I attached to this token. Now, you can also specify an expiration time for that token. So it can be a very short-lived duration, or it can be a non-expiring token. And that token is only valid on the installation of BBJ Services that generated the token. Or you can copy your configuration file from one BBJ Services to another, and that way it can share tokens. If you have multiple installations, that should be able to share tokens. Tokens can also be invalidated using the admin API or the enterprise manager. And so that's what's really nice with this capability is not only can you generate them, but you can say, hey, you know what? I don't want this token to be valid any longer. So let's look at some use cases for authentication tokens and why this is actually a cool feature. So this allows you to store things like an authentication token in a configuration file instead of a username and password. I think many of us can attest to the fact that we've been frustrated with different products at different times, knowing that we had to store a user and a password in a plain text configuration file or try and encrypt it in some way or something like that. We just don't feel comfortable having that password stored there. We basically are just hoping and praying that nobody ever opens that file that shouldn't know what that password is. Well, in this case, you can store an authentication token instead, knowing that that password, there is no way to to reveal that password because it's actually not even part of the authentication token. Keep that in mind. It's nowhere to be found. It can't be reverse engineered from that token. That token is a unique way of identifying the user that the server has said is valid for it. Now, you also don't have any need to remember the username or password when you have occasion to need to reconnect to the admin API or the SQL engine. So again, this is a common scenario where applications often have to remember a username and password and keep that in memory. Again, that is a bit of a security risk anytime that you keep that password anywhere in memory or on disk. And so in this case, again, you can log into the admin API, get yourself a token, forget the username and password, and now that token identifies the user instead. And then finally, you can provide a temporary way for a user to access a database that expires after a particular period of time. So again, another use case, and I'm sure that you can come up with a number of different use cases for using these authentication tokens yourself as well. And this brings us to the last area that we wanted to cover in this particular session, and that is the ability to export your database definition to either HTML documents or to a MySQL-compatible SQL script. So when it comes to the HTML export, this generates an HTML document structure that describes your database. You can select the items that you want to include in that export. So you can include some tables, but not others. Just depends on who you plan to pass this information along to. It also allows you to include SQL and BBJ specific pieces of information in those exported HTML files. The HTML files will have hyperlinks that allow you to navigate through the entire document structure so that you can walk through the various pieces and components of your database definition. And this makes it very easy to share with those who need to understand the layout of your database, but maybe you don't want to give them access to the enterprise manager. So this is a great way to do that. You can zip up these HTML documents into a package, pass them on to your third-party developer. They can understand your database, but they don't need access to that enterprise manager. This new export feature also allows you to export your database definition to a MySQL-compatible SQL script. So it generates a MySQL-compatible SQL script, which will include the items that you have selected. So again, you can select the items you want to include or exclude from the export. And it generates appropriate create table, create view, create index statements, as well as alter table statements. It puts all of those into the script as necessary to best replicate your database definition. It generates appropriate SQL, then those would be the alter table statements to designate your foreign key relationships. That is, if they are supported by the data dictionary that you have, that would be an enhanced format data dictionary or a ESQL tables. Those have established foreign key relationships. So it will include those in the exported SQL script, again, if those are available. And then the script can be imported into another DBMS or various visual and design tools. And so we're going to be taking a look now at a demonstration of how all of this can work and why you might find this really useful. So let's take a look now at this new export feature in the Enterprise Manager. So we're looking at the databases page here, and we see a list of our databases, and we've selected the add-on software database. We'll click the export button, and that brings up the wizard that we can then choose the format that we'd like our export to be in, as well as the location that we want our exported files to be created. So we're going to export it to this particular directory. We hit next. Now we can select the tables that we want to include. So we can include all of the tables or just a subset of the available tables, whatever you need. And then we click next, and we can do the same for views, stored procedures, sequences, type definitions, and so forth. And once we're done, then we hit the finish button, and that creates a series of HTML files in that particular directory. So let's take a look at what that looks like briefly here. So we have our export directory here. And as you can see here, we have all of these HTML files. So what you would do is zip up all of these files and send that to the person that needed to have access to your database definition. And then they can unzip that and open it up. It's basically a standalone piece of documentation that allows them to navigate through the structure of your database. So let's take a look at what that looks like when it's opened in a browser. So we have the add-on software export open here in our browser. And you can see here we have links to a number of the pieces of information that are available to you. So we have our database settings, so we can click on that and see those settings at a glance. We also have our tables, views, and stored procedures. So let's go ahead and drill down into one of those. As you can see here, this probably looks somewhat familiar to the Enterprise Manager. It's a read-only view of that database definition with all of the tables, the file names, the file type, number of rows that are in that particular table, and the description. Then you can further drill down and get the specific definition for that table. So you can see here we have all of the column definitions, the data types, the lengths, as well as a description for each column. So you can see how useful this would be to be able to pass on this read-only definition of your database to anyone that may need to understand the structure of your database, whether that's another developer from an outside company or someone who needs to be able to build reports within your own company. So let's take a look now at what happens when we export to SQL, because that is another format and it's going to have a bit of a different use for it. So let's take a look. If we had exported that to SQL, this is what we would see. We'd see a list of create table statements here, and it's following the MySQL SQL syntax format, so that it's a very common format. What you see here also is a list of alter table statements that define the foreign key relationships between each one of those tables. Now, in this particular tool that we're using here, we're importing this SQL script into it, and it's going to give us a visual description of our database using an entity relationship diagram. So let's take a look at what that looks like here. So we're using dbdiagram.io, and it's a free website that allows you to visualize your database definitions. And as you can see here, we have all those tables that are defined, and we can zoom in or zoom out to see any level of definition that we want to see here. So we have the ARM cust ship table here, and we can see the various foreign key relationships defined here when we hover over one of these little foreign key indicators. So you can see here we're looking at the ARM cust mass table. And let's move some of these out of the way here so that we can more clearly see some of these descriptions and connections here. So you see the ARM cust mass table here has a country ID field, and that there is a foreign key defined up to the ADC country table here. So you can see this nice visualization here of your database. This is a great way to document the structure of your database too, because you can see how everything is laid out and related to one another. So this is just one example of how you might use the SQL export to visualize your data. You could also use it to import your database structure into a MySQL database or something like that. So there's lots of different use cases for this particular feature. And that brings us to the end of this particular session. So as a summary, let's just review what we covered. So we talked about some of the key features of the BBJ DBMS, kind of a little reminder of those features. We talked about replication enhancements and improvements and how to include it as part of a disaster recovery strategy. We also talked about how replication now has support for encrypted tables and data files all automatically. We also looked at full text index enhancements and how to use those multiple analyzers per field and benefit from that new feature. And we looked at some security enhancements. And then we finally wrapped it up by looking at the brand new data dictionary, HTML, and SQL script export capability.